welcome to the Cannabis Data Science meetup group. So we're always here just to crunch numbers, have fun, have a good time. So we've been looking, we started on the West Coast, started in the Northwest, looking at Washington. So we looked at all the Washington state data, then have been gradually moving our way east, looked at some Colorado data, and then spent a bit of time in Oklahoma, crunching numbers in Oklahoma since they've just come online with medical, not pretty recently. And so things are shaking out there. Then continuing through the Northwest, looked at Illinois and Michigan, which both have interesting markets. So Michigan has had medical for a long time now. So people in Michigan, cannabis is nothing new to them. And there's some established businesses there. There's some thought leaders there. Great scene. Illinois is interesting as well. In Illinois, my main takeaway is that there's a bit of a license cap that's really defined the industry there. So there's only, a couple dozen licensees. So there's not much competition there. You see some fairly high prices in Illinois, and they are moving in the direction of, okay, we're going to allow some micro businesses. We're going to allow some craft growers. So we'll see the direction Illinois goes. So it's much different than the other states. And so now we're just continuing moving east. And so here I'll go ahead and share my screen and share what we've done and are doing.
Awesome.
Right. So Cannabis Data Science Group, it's put on, hold on, I'm just getting cut. So put on essentially by, Canlytics. And so here we're, just going to be hosting some of the data. And so as we've noted, the map's getting quite filled in here. So we've got recreational states in the darker green and medical in the lighter green, and then not permitted in tan. So there's only a dozen or so states that have no cannabis permitted at all, including my home state, North Carolina. And in fact, at the Cannabis Science Conference, I've been speaking to someone who works at a hemp laboratory in North Carolina. And they were also lamenting on the fact that North Carolina is, battling to be, last in the game.
Yeah.
So it will be interesting to see if so, then when some of these other states may come online. And so to get an understanding of, okay, what may they look like when they come online, let's start looking at some of these northeastern states. So keep in mind that the map may be a little misleading. So Virginia is shaded green. However, they won't technically have recreational sales until, I believe, 2022 or 2023. Okay. Oh, got Paul, who's a regular, joining here.
Awesome.
Well, welcome, Paul. So, sort of small crowd today, but that's okay. So, we're crunching numbers nonetheless, and we're essentially looking at the East Coast today.
Very good. I'll just listen in for now, Keegan.
Okay, we can have a bit more of a back and forth later because there's a lot to talk about.
Yeah, sorry for being late.
Oh, no. Glad to have you. So essentially we were saying, okay, we're looking at the East Coast, but some of these states aren't coming online yet. Virginia's not online yet. I was looking, and New Jersey may have some existing medicinal laws on the books, but their recreational program is not up and running yet. It does not appear. And then New York is not quite up and running yet. So that leaves us to these other northeastern states. And so let me just tab anymore. So just to show you some of the data that we found here. So Massachusetts has some good public data that can be accessed through an API. So I have poked at this data before, so this is worthwhile looking at. Maine is, they're making a laudable attempt to make their applaudable attempt to make their data accessible. It's a little hard to get though. So from what I can tell, they may only have the past 3 months in sales data, and they do have a list of licensees. However, a little hard to extract this data. However, where there's a will, there's a way. So we may have to revisit Maine, but what I stumbled upon, which I think we'll find quite interesting, is Connecticut has done an outstanding job at making their data available. And so here's a data point that I think will have fruitful analysis moving forward. So we essentially have, we have the number of registered patients, and we have the registered patients per county. And so I think this is an interesting data point because remember before we were looking at, what's the total number of licensees per capita? Well, it would make a bit more sense to look at licensees per patient. So, so we can understand, how many licensees are required to serve a set number of patients. So interesting data point there. And then the data that we'll be diving into today, which I promised a while back that I would try to find some, and somehow coincidentally stumbled upon some. So essentially a long time ago, I said, wouldn't it be interesting if we could find terpene data? Because there's so much more emphasis on terpenes these days. So it would be nice to have a measure of various terpenes that are out there. And lo and behold, Connecticut appears to publish what they call their brand registry. And so I am not certain if this is every single product that is sold or just a running list of various products that get sold. And so that's what we will be trying to discover today. Is essentially we've got a data set here of just shy of 11,000 products. And what's really cool about this is we have a lot of data here. So, a picture's worth 1,000 words. So, for example, we have, well, this looks like just a stock photo, but, real cannabis flower. And corresponding with this, they also have the certificate of analysis. So, this is, verifiable data here. So we've got, we've got our data set, and we even have the certificates of analyses to go along with the data. So quite a defensible data set here. So without further ado, let's dive into it. Unless Paul or Hastings, you don't have any thoughts or comments or anything yet, or?
Not for me, Keegan. It's just nice that they were able to put all this together around the actual product.
Exactly, because it would be incredibly interesting to tie these to sales. And so I'm sure the state could probably do that. And so we can at least start looking at, okay, what's the distribution of cannabinoids for various products in Connecticut? What's the distribution of terpenes? So those are good measures. What products are being sold? I always think that's an interesting thing to look at. Is a lot of the cannabis industry kind of oddly comes down to cool sounding names. Not always, but what's in a name. So I always think that's something that's worth exploring. But anywho, let's just get this data is the first step. So there's a couple ways you can get this data. One, you can just, let me see here. Yes, so you can just download this data for whichever format you need. And then it's also available through two APIs. There's the Open Data API and then the Socrata Open Data API. And so have essentially just read in this data here using the Socrata API. So that's easy enough to do. Hold on. And let's just ensure that we have the data here. Awesome. So let's see. It looks like the API may have slightly newer data than is listed here in this table. So here there's 10,791 observations. And when we query the API, we have 10,801. So I find that curious. So perhaps new products have been added. Perhaps there's a discrepancy. So we'll maybe uncover that as we go. And so first things first, we can look at the data. So I realized, oh, you can actually open a little data frame here in Spider, which is interesting. So, this is just the same data we've been looking at. And so, we'll want to look at the terpenes and the cannabinoids. So without further ado, I'll just essentially be coding this up as we go. So I would have liked to prepare a bit more, but we'll be looking at this data set for the first time together. So hopefully, at the very least, I would just like, unless you have some data points you want to look at, essentially the main data points I want to find are, one, what's the prevalence of the cannabinoids and terpenes for the samples. So so this is basically going to be, okay, so what percent of the samples have a given terpene? Because that was the first thing I noticed was, okay, so we're looking here at terpenes. If you start looking at, say, just picking one of these out of your hat, you just start looking at limonene here. Well, you'll see, a lot of samples don't contain any limonene. And then, the ones that do, they may contain 0.5%, 1% there. I just saw one like 3.7%. So essentially, to me, those are the interesting data points that jump out to me is one, what percent of this sample even has limonene? And then two, of the sample that does have limonene, what's the distribution? So if you're growing a strain and you expect it to have limonene, what is a high amount of limonene and what's a low amount? So we can try to answer those questions right now. And then the third question was, and then that will essentially help us answer the third question was, what's the most prevalent terpene? And actually, they were mentioning here at this Cannabis Science Conference, an interesting thing about terpenes here is it may not necessarily be the amount, but more the presence. So you say, oh, you know, beta caryophyllene here, it's got a quite low concentration, right? You've got less than 1% here. But what they're finding is it's more just the presence of it that matters. So just having the presence will give you that effect. And I think they were saying that beta caryophyllene may even be quite it may essentially be one of the more intoxicating terpenes. So this one may be one of the terpenes that actually gives you one of the intoxicating effects. So let's just crunch these numbers. Okay, so the first thing I noticed was, so let's say we're looking at beta caryophyllene. And also, I may have bad typing today, but that's okay. So let's just say, okay, so let's say, okay, what are the values here that we may expect for beta caryophyllene? So a lot of times I'll caution, if you're going to do this with a numerical series, you may end up with just a giant list. But what I notice here is, okay, well, first off, they're all in strings. So we're going to have to convert these strings to floats. And then I noticed there is this occurrence where they basically say, oh, there's less than 0.1. Well, when you're measuring analytes at a laboratory, you really can't quantify something as 0. You can only quantify it as not detected. So the laboratories have a detection limit. So they can only detect analytes above a certain threshold. So the laboratory can only, in this case, I bet, could probably only detect beta caryophyllene of amounts greater than 0.1. So they probably code Nondetects as less than 0.1. And so I would like to just go ahead and code these as zeros because, just for handling this in our analysis, it will be just fine to just handle those as zeros. So essentially, that's where we are at right now. So, so first things first. there's probably more elegant ways to do this, but essentially I've just listed the terpenes here and was just going to iterate over the terpenes and fix those values. So basically, so
Hey, Keegan, I also noticed
yes.
that in some of those values, they have a percentage sign on there as well.
Yeah, so 1.31%. Exactly. So we'll have to replace these percentages. So hopefully once we do that, we can convert these to floats and get these. So let's see here. So upload. So let's see if this starts with less than 0. Okay, I may not be doing this iteration correctly. Here, the way I think I would like to do this is basically for terpene and terpene. The way I'm just going to do this is, data dot. Okay, so let's just replace. Okay, I would like to just replace all of these, but we may just have to do them. Let's see. If this will just clean up these terpene data. Okay, so in fact, that was maybe not entirely what I wanted to do. I actually probably wanted to replace this with zeros. However, that essentially worked to just have to get the data from the API one more time. Okay, and so we've done that one to do, and we've also done a second to do. Okay. Okay, so next step, just to show you the whole data wrangling process from start to finish, and hopefully finish with some cool charts. Oh, that's not good. We may have. See, ideally, I would like to just do this with what's called a regular expression, where we just catch everything that begins with a less than, just for the sake of speed. I'm just going to try to hard code in all of the ones we see. Okay, so now I think we should be able to maybe plot some of these. So let's see if we can't. So for example, okay, so let's find all the data with limonene, which is what we'd set it first. So limonene. So let's just say data dot limonene, or right, we want the data where actually limonene as type float. Greater than 0. Let's see. I don't think this will necessarily work, but perhaps. Wait, it looks like that actually worked. So now we just have a data set here. So, and we'll do this for all the terpenes, but just to do it for one first, just to see what, just to kind of figure out what we're doing here. Interesting. So now we can see, okay, what percent of the sample actually has limonene, and the higher proportion than I thought. So about 30, about 35% of the samples have limonene, which I think is just such an interesting observation, because it's a large proportion, but that still leaves 66% of samples that don't have limonene. So so is this a popular terpene? Is it not a popular terpene? I think it's too early to tell. So
Keegan, without the benefit of any lab knowledge or experience, so for limonene, were you saying? No, I think you're talking about another terpene that might have more of an effect on the user. But why the interest in limonene?
Well, so I guess I should have filled you in here. So at the Cannabis Science conference yesterday, they were mentioning, there was a really interesting speaker from Israel who's done some research at the Technion Institute, and so they're really leading the industry with data science there in Israel. And so what they've basically done is, okay, they've got all the medical patients in Israel essentially on a database, and then they can report their purported effects into the database. So that way, okay, they say, okay, the patient, they bought this strain and they purported these effects. And so they're essentially trying to, I guess, match prevalent terpenes with common effects. And essentially these are, I think, some of the top, these are, I think, essentially some of the most prevalent terpenes you see are myrcene, limonene, linalool, and beta-caryophyllene. So I want to say that those in their studies were just the most prevalent terpenes.
Okay.
So I think that, so that's why I picked them out. I'm going to I have it recorded, so I'm going to have to re-listen to the recording, because there was a specific reason I jotted those terpenes down. I want to say it was their prevalence, but we can but that's a good question, Paul. So I'll have to maybe follow up, send you a message afterwards.
Yeah, no worries. I just was curious. Yeah, thank you.
I want to say they're the most prevalent.
Okay.
So what we can actually do is see, okay, which ones are the most prevalent in this study. So actually, we can probably do that here in 5 minutes. So we'll just say, okay, what's their prevalence? Okay, so for terpene and terpenes, we'll basically want to do what we just did with limonene, but just do it for, a specific terpene. And let's see if Connecticut, so basically my prior is the top 4 will be myrcene, limonene, linalool, and beta-caryophyllene. But we'll find out here shortly. And so we'll just say I'm not sure if prevalence is the right word here, but for now we'll just use that. And so we'll basically say, oh, well, that's just going to be the amount that this terpene was actually observed. Okay, so it looks like we may still have an odd character or two. Wonder. For some reason, I don't think that'll work. Okay, just a few more odd characters in the mix. Okay, let's get the data one more time and try this again. Okay, so this is why I kind of wanted to, you bear with me. See if we can't. Let's see. Let's see here if we can't just replace everything that's 0 point anything. Let's see if that may just. Okay. I'm going to do this once or twice, but if there's many, we may have to. Okay.
Gotta love the data cleansing process.
Exactly. Okay. Okay. We'll call them non-detects. Okay, so let's just try to exclude these real quick. So let's just identify them first. Data.load string. Okay, so let's just find everything that begins with a less than. Okay. Actually, let's just get everything that does not start with this. I wonder. Okay. Sorry that I'm having to. Oh, it looks like we can just use a negation symbol here. Okay, so we can just say, okay, hopefully we can just say, okay, the detects for everything where it does not start with less than. This is a little bit ad hoc. That's sort of what we do here. We're just trying to crunch them quick. So Ah, man. So okay, hold on. May have just introduced a typo. Okay. Okay. Sorry that I'm having to sort of do this on the fly here.
No, it's all good. It's good to see how you go about doing this.
Yeah. Well, I would, like I said, I would have done it here with the okay. So this is how I would normally do it. I would say, okay, remove all strings with the pandas.
I do exactly the same thing in R. I just Google the code
Yep.
if I don't know it.
So, okay. Okay, this looks promising here. Okay. Okay. But that's okay. New data set. We need to get it clean. Okay, so we're saying, okay, the non-detects is where everything begins with a less than. And now I think we can just do not detects. Cool. So hopefully we can just do detects. And then isolate that specific terpene. Okay, just needed to slow down a bit. Interesting. Okay, this is okay. Let's try one more time here. Okay, so the non-detects is where the data starts with the less. Oh, I see what's happening. This one just doesn't begin with.
Got an extra decimal point there.
Yeah, I wonder. As type float. I wonder if we could have done this. Yeah, see, I think we could have done something. So I think this may work a little better. Okay. So we'll just say, okay, this is, we're going to say this is to numeric. Okay, so now we're just going to force everything to numeric. And at that point, we'll restrict everything. So that may work. I think this dot loaf line may mess up. Running not super quickly, but and then final thing, we'll just sort the dictionary. But whoops, I meant to store this as a key. So while that's loading, so we may be able to. So this looks like a magic line that we could use to sort it. First things first. So these are the terpenes and the percentage of samples that they're found in. And so let's see if we can't sort this real quick. Okay, so it's in reverse order. So this is interesting here. So so it should be top terpenes. So trying to think of the best way. Well, I guess we can maybe just try to plot this. That may be the best way. So let's see if we can't just make a quick plot here. So a little bit of an ad hoc day for just to do a little exploratory analysis. So for next week, we can get a bit, now that we sort of have our questions defined a bit, we can, you know, hone in our analysis a bit better. But we can still make some charts for today just to begin to visualize the data. Okay. I think we just need to do prevalence side. Use. Hopefully we can just plot. Okay, so okay. So this data is just not collected very well. Because I really just want to get this sorted here. Sorry, just sort of thinking on the spot.
You may not want to go there, Keegan, but I mean, you could always export to CSV and just pivot it around in Excel or something.
You know what? May not be a bad idea real quick. So, let's just make sure. Okay. Okay. Okay, so now we can get this to Excel. So not pretty today, but we've at least begun. We can at least answer a question. So that's good.
Yeah, it doesn't have to be pretty.
We get. I mean, we're about to figure out what are the most prevalent terpenes in Connecticut. So
Yeah, it's pretty cool.
So yeah, so simple enough now. So now we can just sort. Okay, so this is going to be the terpene, and then the the percent of samples that is present. Okay, and we actually want to sort this by the percent of samples where it was present, from largest to smallest. Okay. So, I have not actually heard of this terpene. It looks like beta udesmol. So I'm going to need to do some homework. I have heard of Fenchone. So I do believe that Fenchone is what gives cannabis its its distinct cannabis smell. So so that would make sense why it was detected in 96%. So I would even question what's going on with those last 4% of samples. But it looks like you could, and camphor too. So I think these two terpenes, camphor and fenchone, I think that's just integral to the cannabis plant, and that's what gives it its unique smell. And then moving on down the list. So let's say, okay, I'm going to need to do some homework on this one, but it looks like these three may just be present in cannabis in general. So maybe that's why in Israel they weren't really looking at camphor or fenchone, because they may just be taking that as a given. So then what I find interesting is, okay, so let's say those are just the given. So then, yes, if you look at these, our top, 4 after those would be the beta caryophyllene, which I believe is what you would. So I think they were saying that this is essentially would be the best indicator if something's an indica or a sativa is, does it have beta caryophyllene? And so this is what's going to give you the sedative sleepiness, I do believe, is beta caryophyllene. And so just from this, it looks like, about half of the samples are what you'd call indica. And then moving down, there's the limonene, which is also on their list. And, a lot of these terpenes you can find in other things. So, of course, lemons. Humulene. Don't quote me on this, but I've got this sneaking hunch that may be a similar terpene that's found in hops. So don't quote me on that one though. But I think this is an interesting find because this wasn't one that I was expecting to be here in the the top 4. And then of course you've got beta myrcene, another one that I believe has a purported sedative effect. And then linalool, which was another one, and then this one comes in at the 5th. So that was one we were kind of looking for. And so if you just look at the breakdown of the numbers here, it looks like this is almost like another pack of its own. So, about 30 for beta caryophyllene 50. So, but for these ones, about 35% of all samples contain these terpenes. And did you have a question, Paul? Or?
Yeah, Keegan. So the conference that you're at, the science conference that you're at with the Israeli group, and some of these items, these terpenes that they had mentioned, you said they're testing with their medicinal group to try and capture some subjective feedback from the users and then kind of match it with correlate it with the terpenes.
Exactly. So they're really going after the medical benefits of the various compounds.
Mm-hmm.
So from terpenes all the way down to the cannabinoids, and so they're just doing a real data heavy approach. So they're saying, oh, this patient, maybe they're suffering from, it could be cancer, or maybe they have, I'm not certain, but maybe they have anxiety, or I think it's typically more severe conditions, like epilepsy, cancer. I don't know what the big ones are, but they're typically pretty severe. And so then I'll have to tell you more about the data collection process in general, but from my understanding, they've got just a medical patient registry, so that they see, okay, this is how much this patient is consuming, and then maybe they fill in surveys where I'll need to get you more information about the surveys, but that's my understanding.
Okay, yeah, that's interesting. Thanks for sharing that.
And I think it's quite different and interesting research than anyone else is doing, because they're just going so heavily after the medical effects.
Mm-hmm.
That's just what they're heavily focused on, and they've got data like nobody else does, because they essentially, I believe, have the whole population of medical consumers, in their database.
Okay.
And then they, also have all the data about all the crops being grown. It's just, here in the United States, I mean, we don't have any good measure of the medical program in California, or
they've got a centralized system as opposed to ours.
Exactly. So they're able to do a bit more of sort of the almost controlled experiment type things,
mm-hmm.
there, and which are needed for to make any determination about medical effects of these compounds. But
Very cool.
so I'll have to fill you in a lot more. So because there's been a few things that have caught my interest. Some things have come to light. So perhaps for next week we could continue this conversation. Ooh, and real quick, why don't we just plot just to end the day with we'll go all the way down to pure gall. So that's interesting. I remember that terpene. Let's see. Yeah, we'll just there we go. And so this is just the prevalence of terpenes. And so next week we can start to look at, okay, what's the actual distribution of the concentrations, and maybe we can even do some correlations next week and see, okay, are these terpenes correlated with any cannabinoids or what have you. So, but, and so my last remark is, okay, so these may give you an idea of these are the most prevalent ones, but don't necessarily throw these terpenes out, because what I was learning is, okay, even if a terpene's present in a real low concentration, well, these are just rare. So if you find a strain that reliably produces one of these not so common terpenes, that could give you a competitive advantage. And then the other thing is, say your plant maybe only produces beta caryophyllene in a very small amount. Well, that may be sufficient, because basically what they're saying is a lot of these times it's like when you're like, it's like your titration, like when you're taking like a medical product, right? It's easy to take too much. So like you get, like the idea is you may only need a little bit of beta caryophyllene to get the effect, and then if you overdo it, it may become unpleasant. So that was something that came up, was it may not necessarily be all about the concentration, but more just the presence of various terpenes.
Yeah, and I wonder if there could be almost kind of opposite correlative effects of different terpenes. I don't know if that's even feasible, because I don't know anything about them. But as you increase one, maybe it negates the effect of the other, or maybe having a combination of them together has a certain effect. I know.
Well, you raise a real interesting remark here. So, a chemist once told me this is, I mean, basically your plant can only produce like so much stuff, right? There's only like so much room, right? There's only like 100. It can only be like 100% of the particles, right? And so it even actually comes down to the point where you may be, right, your plant may be producing a lot of terpenes, and if you're spending a bunch of energy on terpenes, maybe you spend a little less on cannabinoids. So you may have something that's real high in linalool, and because of that, your THC or CBD may be slightly lower. And if you're breeding just for cannabinoids alone, then you may like ignore these high linalool strains or what have you. But those may actually be what consumers are looking for, because the high terpene concentrations, those are going to be the varieties that have real strong smells and may even have strong effects.
Yeah.
So
this may be already known. I'm jumping in headfirst in a lot of things that I don't know about yet, which is exciting. But what, in terms of determining how a customer or consumer is responding to, I mean, in this case, the different maybe a ratio of terpenes against each other. So you may have like, I don't even know how to pronounce the beta caryophyllene, and say you've got 60% of your terpene count is like in that, and then the rest of it is split up amongst 5 others. Is there some type of performance metric that's like gauging a customer response to different strains that have these different levels, or is that all very new still?
It's new, and like I said, basically that's essentially what the people in Israel are after, is because what they notice is cannabis is so there's so many different varieties. So you look at one variety to the next, like the terpene profile is just going to be completely different. And so that's why I guess they're really going after big data, because like if you're going to try to disentangle the effects, you may just need just a giant data set where you just have, you know, thousands and thousands of cancer patients that have tried thousands and thousands of different varieties, and they all have different terpene profiles, and then you can maybe try to disentangle it. But I think it's basically a puzzle that people are running into. It's basically cannabis is drawing a lot of attention from people. We're trying to figure out why. There's a lot of compounds in there. And from my understanding, there's not been that many great patterns discovered, right? Like I think people are starting to discover things like, oh, maybe like beta caryophyllene is kind of intoxicating, and maybe that explains its prevalence because people are actually breeding for beta caryophyllene and they don't even realize it. So I think it's all new. Were you going to say something?
No, I was just saying, I think that's really interesting. It's, I mean, at least here in Texas, it's all very, very new. I think they just last year allowed the sale of Delta 8. So you're seeing that pop up everywhere. But yeah, this is all very interesting information to me.
Yes. And we've looked at Delta 8 in previous weeks, and we noticed that Delta 8's actually not that prevalent. So I believe, and so I think if you basically found a strain that was producing high amounts of Delta 8, then that could be a winner. So, but then it's like, what makes it produce a lot of Delta 8? It's like, oh, and this is where Paul mentioned, is that maybe correlated with a terpene?
Sure.
And so this is where we kind of get into the chemistry of things. And then this is not my expertise, but I think it has a lot of value to be added, is basically, right? So a lot of these chemical compounds are structurally related. So if you have, you know, a high prevalence of one terpene, it may kind of break down into various other compounds further down the line. So it's sort of like how the terpenes degrade, how the cannabinoids degrade varies as well. So there's a lot of variation going on.
Interesting.
So I think go ahead and conclude there, since we've gone a bit over, but just want to, you know, thank you both for coming today. So by next week, I'll probably have digested the Cannabis Science Conference a little bit more, and I'll have reviewed my recording so that way I can share my notes with a bit more confidence with you. So the next week should have a bit more to share, and I'll have spent a bit of time to actually do some of these terpene charts and some of the terpene analysis. So that way next week we can go a bit more in depth and not spend the whole time cleaning the data. So.
That was useful, and thanks, Keegan. I'm actually out of the country next week, so I'll miss our next conference. But thanks for sharing the Connecticut data. I think I want to take a look at that just from more of a marketing perspective. some of the retail sales stuff.
Exactly, because they have the product information, so you
Yeah.
can see what's selling in Connecticut. So
Yeah. I want to take a look at that. So thanks for sharing it.
definitely, and I'll send you the links and whatnot afterwards.
Okay, great. And nice
Awesome.
to meet you, Hastings.
So,
Yeah, nice to meet you, Paul.
so thank you both for coming, and until next week or the week after, stay productive as always.
All right. Thanks, guys. Bye.
Bye.
Bye.